Thank you for applying my interviews for this time. So I want to ask the question is why did you choose to study in the field of computational photography like this?
Okay, so when I was a student, that term did not exist. Okay, so I studied physics, and then I saw that I enjoy images, just for aesthetic reasons and being a photographer. So it attracted me, and then I went to learn more on computer vision. So this combination of computer vision and physics basically drew me to what was then called physics-based vision, which is part of what you call now computational photography. And later on, I found that I have creative ideas in this domain, so I enjoyed it and I remained in the field.
Thank you. I think so too, because yes, computational photography is the combination of the physics and direct optics and the yes computer visions tasks. So the second question is the it is the quite a bit different, a bit difficult, but what new technologies do you think will change the computational photography the most in the next years?
Okay, so I think we need to be aware that what we call computational photography, which is advanced processing and interesting ways of doing sensing, is done in other communities of science and engineering. They just don't call it this way. They call it other ways, like, I don't know, medical tomography, seismology, radar. All sorts of other communities who are doing essentially this: how to sense, how to illuminate, how to. So this kind of a question is more broad. I think there will be more and more collaborations between our community and these other communities, where we'll learn to learning their models and we will affect their models. That has been a trend for several years, and that will continue and accelerate. The other thing is that more powerful computing, partly due to deep learning, enables much better engineering, and through that better engineering, there are better optics, better illumination suggestions. Now we can see here meta optics, new types of detectors. All these things, through better computing, enable better engineering, and that, of course, propels our field to look into new interesting problems.
Thank you. So the collaboration can change the computational photography fields in this field. Oh, that was yes, that was important. Yes, I was impressed that this answer. So thank you. So the next question is that is there anything like tips do you have for students who want to work in this computational photography field, like me or something?
Yes. I think it's a general advice to any student is to enjoy, not to do something that somebody else says is important unless you really like it. So do something that you like, do something that you feel passionate about and creative about. If you're creative in it, it means that you enjoy it, it means that your mind likes to think about it. And if something is very important because many people are doing it, but you're not creative in it, it's not for you. So it's a general advice, irrespective of the field, I think.
Thank you. I will remind these words in for the future in my student. Uh, so yes, next question is the, can you tell me about a time when you had a big problem in your work, and how did you solve it in this time?
Well, there are different types of problems. Sometimes the problem in the work is that you don't succeed. Sometimes that you succeed, but somebody else is succeeded before you. Sometimes it's that you don't have enough funding to fulfill your vision, and sometimes it's that you have too much money, but you don't have enough students to use that. So these are in the career. There are all sorts of problems that are being thrown at a professor. Some of them, as I mentioned, are technical, and some of them are more about human problems and management. I don't think that I have a good advice any better than anybody else. I think that we all learn from experiences. When I was in my younger, my earlier stages, I got a lot of advice from older people. So I would, as just like you're asking me, I would come to them and say, "Look, I didn't win the grant. I didn't win the proposal. Please look at my proposal. Let me know what is wrong in it." Okay, so I was learning. I was asking advice from people who were more senior and more experienced, and they would have level head, and they would calm me down, and they would give me some good tip on something particular. Uh, but then, of course, over the years, I still make mistakes, and I learn from them. I hope.
Thank you about that in like this time. So yeah, it was so good advice for me. Yes. So uh, the final question is that how do you work with people from other fields like that, or physics or computer visions or other fields to make your research better? How do you work with people from other fields to make your research better?
Um, I try to talk to them and understand really what their scientific problem is, what is their model, and it takes time. I ask them questions and I tell them, look, I don't understand what you're talking about. I need to understand really, really well. And if they cannot explain to me what they're into, I don't manage to work with them well. But if they manage to explain it to me, not as an expert in their field, but somebody who's outside their field, but still explain to me in a good way, then we can work together. But I definitely invest. I don't just take for granted what they're saying. I definitely invest in reading their material, asking them any question about any jargon, any term. What's the meaning of this? What's the difference between this and that? And but it's a learning process. Sometimes some things I think I understand when I start to work with them, and then a year later I understand that I didn't understand correctly, but now I understand better. So I am trying to understand what they're doing, not just saying I'm doing my part and that's their part.
Thank you. Yes, program and model and time. It was so. Thank you. It was so important. I think so. Thank you for this interview.